Hi, this is Mrs. LaBarbara. This is Physics Chapter 4, Two-Dimensional Motion and Force, Video 6. Today's topic is force at an angle. The objectives are to know addition of forces and resolution of forces, to understand the condition of equilibrium, and be able to solve problems involving forces at an angle. Let's review adding and resolving forces. So force is a vector quantity. So we have done how to add and resolve vectors. So force is just a special case of vector. Force is vector quantity. It has magnitude and direction. The vector sum of all forces is called resultant. We have a special name that's called the net force or unbalanced force. So when adding forces, it's just like adding vectors. We first must resolve all forces into x and y components, such as this. Force at an angle, we have to find fx plus fy equals to f. To find fx equals to f cosine theta, and fy equals to f sine theta. Then we have to add all the x components to find sum of the force in the x direction. That's the net force in the x direction. And that should give us ax times m. That's Newton's second law. Similarly, we can find all the forces in the y direction. That should give us fy, sum of fy equals m times ay. Usually, in regions physics, the object is only moving in either x or y direction. So only one of them is not zero, the other is zero. The first special case is equilibrium or statics. So when all forces acting on objects are balanced, the object is in a state of equilibrium. In this case, all the force in the x direction has to be zero, so there is no horizontal acceleration. The forces in the y direction is also zero, and there is no y acceleration. An object at equilibrium is either at rest or moving with constant velocity. That's Newton's first law. Let's take a look at this first example. Determine if a system is equilibrium. So forces A, B, and C are acting on an object. As you can see here, A is at an angle, B is to the left, and C is down. Determine if they produce equilibrium. Is this object in equilibrium? So to determine if the object is in equilibrium, we have to find all the forces. If all the force in the x direction is zero, and if the force in the y direction equals to zero. Basically, this is a vector addition. To add vectors, first we have to resolve forces into x, y components. Take a look at A. Ax equals A cosine 36.9, which is 5 times 36.9, which gives us 4 newtons. And Ay is A sine 36.9, which gives us 3 newtons. Similarly, for bx forms an angle with x 180 degrees. So bx equals negative 4 newtons, and by is 0. B has no y components, and C has no x components, and y components is negative 3 newtons. We add all the ax, bx, and cx together to find fx. That gives us 0. We add all the y components together, that also gives us 0. What does this say? It tells us the system is in equilibrium. Another example, determine individual force in an equilibrium situation. So you probably have seen this frame at home is hanging by 2 wires, and the frame is in equilibrium. The frame is at rest. So when a sign is hung at equilibrium symmetrically, the tension in each wire is shown. 50 newtons, 50 newtons. In this case, what is the weight of the frame? So the angle between the tension and the horizontal is 30 degrees. So how do I find this? First, you draw a free body diagram. There are 3 forces, tension 50, another tension 50, and you have the weight. The 3 forces balance out each other. So what's the first thing we have to do? We have to change force at an angle into horizontal and vertical components. So we kind of scribble it out. We change that with ftx and fty, similarly ftx and fty. So we know that the sign is in equilibrium. That means all the forces has to cancel out. The x has to cancel out, the y has to cancel out. Well, x kind of pretty straightforward because the one on the left has to be equals to the one on the right because the two forces are the same, the angle are the same. The y is the one we can use to figure out what the w is. Since you have two ty's, so 2 times ty has to be equals to w. How do we find the y component of the tension? Y component is t times sine theta. So 2 times 50 times sine 30 equals w, and we have w equals to 50 newtons. Solving force at angle problems. So it's the same thing, right? We solve the force directed at angle. First, you have to resolve force directed at angle into two components by applying fx equals f cosine theta, fy equals f sine theta. Then we have to add all the forces by components to determine what is the sum of the force in the x direction, what's the sum of force in the y direction. Then we use Newton's second law to find usually acceleration and or the other quantities. Let's take a look at the example. Determine the net force and acceleration. So here are 4 forces. So one of the forces is at an angle, which is applied force. So what is the first step? We change that applied force into horizontal and vertical component. Horizontal is 129.9 newtons. How did I get that? This 129.9 actually equals to 150 times cosine 30. This 75 equals to 150 times sine 30. Because this is 30 degrees and 150, that is your vector. And this is the y component and the x component. Next, you have to add all the x together. So you'll have going to the right is positive, so 129.9 plus going to the left is negative, or you can plus negative 60, or you can just subtract 60. And that gives us 69.9. And add all the forces in the y direction. 121 is up, 75 is up, plus 196 is down. And that gives us a 0. What does this tell us? That means this object is moving in a horizontal direction. Object moves in horizontal direction because in the y direction, it's in equilibrium. So net force has to be equals to sum of the fx, which is 69.9 newtons to the right. That is the net force. How do I find acceleration? Acceleration equals the net force divided by mass. It didn't tell us mass directly, but from gravity, we can find mass. M equals to gravity divided by g, which is 196 divided by 9.81, which gives us 20 kilograms. Then you use the net force, 69.9 divided by the mass. That gives us the magnitude of acceleration, which in this case is also to the right. Acceleration, net force are always in the same direction. Let's take a look at more examples. This example is pulling above horizontal, determine Fn and acceleration. So a block of 10 kilogram mass is put along a frictionless horizontal surface with a force of 100 newtons at an angle 30 degrees above horizontal. First, draw a free body diagram. This is the key. It's like kinematics. You have to write down what is given. For force problem, you need to draw a free body diagram. Next one, you need to determine the normal force and determine acceleration. So here is a free body diagram. There are only 3 forces: normal force, gravity, and applied force. There is no friction because it says frictionless. One thing we need to do is, the first thing is the force at an angle, change it into horizontal and vertical component. Horizontal is applied times cosine theta, vertical is applied times sine theta. Then we have to add all the forces together. We already know in the vertical is 0. How do we know? Because the block is moving in the horizontal surface, is not moving in the vertical surface. So all the vertical force has to be equal to 0. That means Fn plus F applied sine theta has to be equal to Fg. From that equation, we can figure out Fn. Fn equals to Fg minus F applied sine theta. Fg is m times g minus F applied is 100 sine 30, which gives us 48 newtons. That is the normal force. So normal force in this case actually is less than the weight. when applied force is above horizontal. That makes sense because the ground doesn't have to supply the whole weight of the box, because when you apply a force above ground, you kind of lifted the box. The ground doesn't have to support all the weight because you have applied part of your force is supporting, kind of pulling the box up. Okay, next one, determine acceleration. So the net force is in the x direction. The only force in the x direction is F applied cosine theta. That equals to ma. To find a, we simply divide m on both sides. You'll have 8.7 meters per second to the right. Here is very similar question, except this one is below horizontal. Again, determine normal force and acceleration. First, draw a free body diagram. This is what below means. Below horizontal, above, below, okay? So again, we need to resolve this force at an angle into horizontal and vertical components. Again, the object is moving the horizontal surface, so all the vertical forces has to cancel out. Fn going up has to be equals to F applied sine theta plus Fg. And that's how we find Fn, which is 148 newtons. In this case, normal force is more than the weight when applied force is below horizontal. That makes sense because the ground does not only have to support the box, it also has to support part of the force you're pushing down. So that's why normal force is more. Now for the acceleration, we have to find net horizontal force, which is just F applied cosine theta. And we find acceleration is the same thing. But this is kind of like special case because it's frictionless. If you do have a friction, because the force is, normal force has increased, the friction has to increase. Therefore, when you're pushing down, your acceleration is less. So it's harder to move something when you're pushing down. It's a lot easier to lift it, to apply the force above horizontal to move it. Okay, another example. A child pulls a wagon at constant velocity, in this case, along a level sidewalk. The child does this by applying 22 Newton force to the wagon handle, which is inclined at 35 degrees to the sidewalk as shown. First, draw a free body diagram. So free body diagram, what are the forces? Applied force, normal force, gravity, and a friction force. So this is again applied is at an angle, so we change that to horizontal and a vertical component. Since it's moving at a constant velocity, so all the forces cancel out. X cancels out, that means friction force and applied cosine theta has to be equal to 0. That's how we can find friction force. Friction force is 22 cosine 35 equals to 80 newtons. We can also use vertical to find Fn since they didn't ask us what Fn is, so I'm not just going to do it. Just find friction, that's what they are asking you to do. Another example, pulling at a constant velocity. This question is very, very similar to last question. I want you to stop the video and try to solve it on your own, then check with answers. Okay, here are the answers. So here's a free body diagram. Change a force at an angle into X and Y. Then you should have horizontal component parallel to the horizontal surface, which is X. Give you 52, and that 52 has to balance force of friction because it's moving in at a constant velocity. That's it for today. Thanks for watching. See you next time.